The important thing that they like to test you is if you have a line that passes through center, or they give you diameter. Okay, they give diameter. So any triangle that is formed in the semicircle will be 90 degree. So any triangle like that will be 90 degree. Any triangle will be 90. So this is angle in a semicircle. This one is popular. They like to test. Next one that they like to test very much is the butterfly. So butterfly, very important thing, 4 points on the circumference. The 4 points must be on the circumference. If not, it's not butterfly. Then the bottom 2 angles are the same. The top 2 angles are the same. So this is called angles in the same segment. So this is another popular one. Next one is of course your quadrilateral. That means also 4 points on the circumference. Doesn't matter how the shape look like, it's just a 4-sided figure. All 4 points must be on the circumference. This one important. So when you have all 4 points on the circumference, then the 2 opposite angle always add up to 180 degree. So this one add up. Okay, add up to 180. These 2 also. Okay, these 2 also add up to 180. So this is called angles in opposite segment. Okay, last one that is popular is angle at center, double angle at circumference. There's 4 cases. 4 types, but all the same thing. So one of it is like that. This is my center. This is my circumference. So this is the center one. This is the circumference one. So this is 2x. This is x. So this one looks like a F1 flag. Okay. Then next one. Same thing, but looks like a rocket ship. So this is your center. This is your circumference. So this one also 2x, this one x. Okay, so this one is like the rocket ship. Okay, next one is the mini butterfly that you often confuse with angle in the same segment. But this one, take note, there's only 3 points on the circumference, but the 4th one is from the center. So this one and number 2 is not the same thing, not the same. Yeah, so this one is the same 2 times, not 3 times. So this one is center, this one is circumference. So take note, if one of the point is at the center, then it's not the butterfly anymore. Don't mix this up. You will normally confuse these 2. This one, there's always a confusion. Don't mix them up. Don't use them anyhow. Okay, so same thing here. This is 2x, this is x. Then the next case, you will often confuse with the quadrilateral also. Okay, but 3 points on the circumference, but 1 point on the center. So this one, you will often confuse yourself with this. So take note, if not all 4 points are on the circumference, they are not the same. This one is angle at center, twice angle at circumference. Take note, I told you all before, the center one, if it is frowning, then your angle at circumference must be frowning as well. You see, I frown. This one also frown. Okay, so this is your center 2x. This is your x. Take note. Don't mix it up. Okay, so this is the other one that is very, very popular. So these four, they always test. It's just which one first. Okay, make sure you know the difference for all the four. The one at the center is the center. This one? It will always converge at the circumference one. This one is at the circumference one. Yeah. This one? This one can because isosceles. That's the only reason. But not because of the flag. Okay? Okay, so these are the popular ones. Then the next one is when I bring in the tangent line. Oh, this one I must write. Angle at center equals to 2 angle at circumference. Okay, so all these without tangent line, but if I add in tangent line, there's only 2 things to remember. One is if I only have 1 tangent line. Tangent means you only touch the circle at 1 point, and then from the radius, if I have a radius line, this one is always perpendicular to the radius. So it's called tangent perpendicular to radius. Okay, but if I have 2 tangent lines, one here, the other one here, and they meet at an external point, then you take note, this is what I have. These 2 will be the same. This one will be 90 degree. These 2 lengths will be the same as well. And if you draw in a third line, this line will cut this angle into half. Oh my god, wailing sound. Okay, so this is tangent from exterior point. Whether you tell me the 2 angles cut into half or whether you tell me the length are equal, it is still this property. Okay, so the whole circle properties is all this. Make sure you know when to use which one. Okay, I can't help you on that. You see what you are given. Based on what you are given, then you go and see what they are testing you. This one must give you diameter. Okay, so that's the whole of circle properties. I shift up a bit. 45 minutes. 45? All along is 45 what? Okay, arc length sector area, very simple. A slice of the pizza. If I want this one, then it's theta over 360 times pi r squared. This piece. Yes. But if I want the red piece, you have 2 ways of getting the answer. One is using circle minus this one. Okay, this is method 1. Or you can go and find this angle, which is 360 minus theta. So 360 minus theta over 360 times pi r squared. So either one will give you the same answer. So this is finding the pizza slice. Okay, so this is area of sector. Okay, but if the angle is in radians, then you just use r squared theta over 2. This is if the theta is in radians. Half. Yeah, 2 pi ma. So you cancel off the pi left 2 at the bottom. Okay. Then this one, same thing. It will be the same old thing, but instead of using 360 minus pi, you use 2 pi minus theta lah. So the same formula, but r squared theta, your theta is this one, over 2. So same method, but when your angle is in radians. This one is also pi r square minus this one lah. Okay, both the same, but one in radians, one in degree. Make sure you know how to find both. Oh, haven't done. Okay, so this is area of sector. But if I want area of segment, also got two types. Segment got minor and major also. So this blue slice is minor segment. The small one, minor segment. So to find area of minor segment, it will be theta over 360 degree times pi r square. I find the whole sector, whole pizza slice, minus the triangle. Yes. Okay, so this is finding area of minor segment. But what if I want the major one? Major one is the whole piece of the green one. Correct. So you can choose to use circle minus away the minor segment, or you can add the major to the triangle. So one way to do it is you use circle minus area of minor segment. This is one way. Just take away this thing right from the circle and then you are done. Or to find this whole piece, you will first find this angle, which is 360 minus theta. So 360 minus theta over 360 times pi r square. You get this thing here. And then you go and plus the triangle. Half r square sine theta. Then you are done. Okay? Yes. Just now, circle property is chapter 10, this is chapter 9. Okay, then of course the last one is arc length. Means I only want the length. Let's say this one. So this is minor arc. So minor arc is just theta over 360 times 2 pi r. But if it's in radians, it's just r times theta. In radians. Okay? But if you want the major arc, the blue line, you can go and find this angle first, which is 360 minus theta. So 360 minus theta over 360 times 2 pi r. Yes, but if it's in radians, you will use 2 pi minus theta, then times radius. So this is in radians. Major arc. Okay, so make sure you know when you are finding what. So this is chapter 9 and chapter 10. All that I can test you. Chapter 9. Because this angle, let's say is 210, it will be out of 360 ma. I need to find the fraction of the circle. So it's always out of 360. Then you know what fraction of the circle. Plus what? This one. Because there's a triangle here ma. The green section is made out of the sector plus the triangle. So this one is the triangle. This one is the major sector. So you add them up. Okay, so the very final last 20 minutes, we will go through set notation. And that is basically everything.
Do you ask us to like draw the
Shading. From the shading, get back what's the notation.
shade?
So either I give you the notation, you shade,
Oh.
or I shade for you, you tell me what's the notation. Yeah.
So no drawing.
No drawing from scratch.
Yeah.
Probably to use to prove your answer then possible.
Who took the paper already?
Nobody. Everybody's taking on Wednesday. Yeah. Just different timing. So y'all don't go to the canteen and talk about the question.
We take it before recess.
Yeah, some people will take it later after.
How
Okay.
we help them?